Checking people on Zoom. Can you type in the chat? Let me know if you can hear my voice and see the screen. Send something in the chat so I know. Good, good. All right, cool. All right, and we're recording. Okay. Hey, everybody. How's it going? Good. Okay. I'm glad we're all here today. And yeah, it's Wednesday of week 5. Wow, we're like almost halfway there, basically. Because we're almost halfway there, we got some cool stuff to talk about. We are going to do a review today because we realize it's kind of a lot when you're first learning Python to get through all of that stuff. And in office hours, we get the sense that there are definitely some of you that need a bit of hands-on review for at least a lecture. So we're going to spend about half of today's lecture reviewing, and then the other half is going to be learning something new. We'll start with the new stuff, and then we'll go into review. And the way it'll work is we have tons of problems that we just made over the past couple days, made them just for you. They're catered towards specific topics, so they're all uploaded to the B courses. I'll show you how to get to them in a minute, and you'll be able to pick and choose what problems you want to work on in a group with the people around you. So announcements. Homework 3 was just due. How was it? Thumbs up good, thumbs down bad, this way middle. It's okay if it was hard, you can let me know. Okay, so I'm getting like mid. It was pretty mid. It's okay. It gets better. The homeworks get a little bit more interesting when we start getting into like real world data. Now that you kind of have the tools for that, they'll get more cool. I think this next one, you actually get to work with COVID data. And you get to plot some pretty functions, and then after that you'll get into some good stuff. So bear with me. The first few homeworks are kind of challenging, but it's getting you to have this groundwork that you can work with on other problems. Like I said, we're going to have a review today. We'll form groups and work on problems together. You can pick what you're struggling on. So if you're struggling on this or that, you get to pick and choose and just work on it that way. Come to office hours. We love to see y'all. We really enjoy it when you're there. It makes us not bored. Yeah, is there any questions? Okay, if there's no questions, let's go ahead and get into it. Yeah, homework 4 will be cool. So let's start with a little bit of recap questions. We won't do like small groups today because we got a lot to cover. But I do have some questions. Maybe we could just kind of spend like a minute or so thinking about these together. My questions to you are, what code do I need to make 2 subplots side by side with each other? We talked about this last time. This is kind of a big idea, a big part of the course, specifically catering towards plotting. And then does anybody remember what np.meshgrid does? What does it do? How does it work? I'll let you think about it for a minute or so, and maybe just think to yourself, and I'll call on people if anybody wants to answer. So spend about a minute thinking about that. Anyway, all right, does anybody have any answers for the first question? That's okay. It's a little bit tricky, and it's hard to just recite code right off the top of the dome, so I don't blame anybody for that. Just remember that we make use of the plt.subplots function. So subplots, subplots, and then you give it the number of rows and columns you want to divide your figure up into, right? So if I give it 1, 2, that means 1 row and 2 columns. That would be 2 plots right next to each other. If I gave it 2, 1, it would be 2 rows in 1 column. So that would be a plot right on top of each other. And you set that equal to a figure and an axis or axis objects. And then you can call on those axis objects and modify them. And we talked about that last time in the slides. It's on the Ultimate Plotting Guide. And if you want, you can work on that today as well with some of the review. And does anybody remember what np.meshgrid does? Yeah. Yeah. So just to reiterate for the people on Zoom, the way MeshGrid works, right? It's a function that takes 2 linspaces, and we remember what linspace is, right? It's just evenly spaced points between a start and a stop, where you can tell it how many points you want. You take those evenly spaced linspaces, you give it an X and a Y, and it basically kind of interpolates it to create this mesh grid. So you give it X coordinates and Y coordinates, and it will make an XY grid for you. That's what mesh grid does. It kind of creates a grid mesh. It's in the name. And you can set that equal to like an X and a Y and use those as if those were X and Y variables in like a 3D function. That's like an f of X comma Y. That's how we use mesh grid. If you just try to do f of X comma Y, it won't know that you're trying to work with 2-dimensional data and create like a 2-dimensional function that has like values at every point. So you need to make sure you use mesh grid to make those inputs work. So good stuff. It's kind of complicated. You'll get more experience with this as we move into the next homework assignments. This one won't have it so much, but the one, or yeah, no, this one does have it, I believe. But yeah, this one you'll be able to get more experience with this aspect of like subplots and IM show, like 2D plots and all that stuff. It's a little complicated until you actually go ahead and start using it. So don't worry if it doesn't make sense to you right now. It will when you start applying it. Is there any questions? Okay. If not, let's get into today's, oh, sorry, I'm jumping the gun. I want to show you the Ultimate Plotting Guide because I realize I haven't really done that yet. And I want to show you exactly what it looks like. So I believe I have it right here. No, here. So this is the notebook. You can download it. It's on vCourses. And when you open it up on your own computer, it'll look like this. It walks you through all the basics. So it starts from the very, very basics, just how to plot a plot with some X and Y data. And then it gradually becomes more and more complicated. So we add titles and figure like labels and stuff, axis labels. Then we start plotting functions, and then it shows you how to plot functions with data and multiple lines on the same graph. Very useful stuff. How to make it bigger, how to add a label or a legend. Then it tells you how to save those figures as like pictures that you can put into, PowerPoint presentations and or research papers if you ever write them. And then right here, it doesn't show, or I guess that's later. Then we get into like subplots and other types of plots. So you can actually plot error bars in Matplotlib. If you have uncertainties in your data, it has that available and it shows you how to do that. How to plot the points on top of the error bars. How to do log scale plots. How do I show the y-axis in log scale as opposed to just regular linear scale, and vice versa? How do I do log versus log? How do I do normal versus log? All that good stuff. There's distributions and histograms. We talk a little bit about that. Then we get into the good subplots and how it works with lots of examples, as you can see. And then we get into like a nice little problem that relates it back to astrophysics and or physics with like black body spectra. And you get to like see like spectrum of stars and how to plot them with redshifts and all sorts of fun stuff. It's a cool problem. It's not really a problem. It's more like just a showing you how to do it. And then I have some really fun one on how to like beautify your plots. So like this is like a before. Wait, there we go. So this is like what the plot might look beforehand. And then this is like when you add some, pretty stuff, change the markers you use and maybe like change the font type and add a little bit of LaTeX in there to make it look fancy with the math. It's all sorts of cool stuff you can do. And then it also talks about other plots. So we have the C maps and the IM show, all that good stuff. How to plot random data. You can even plot images in matplotlib, which is pretty cool. It's Python's logo. How to do scatter plots with like color bars and different opacities. We've got polar coordinates in here. Literally like anything you could possibly find that you might come across, probably the basics are in here. Contour plots, like I said, how to put like arrows on top of it and like little text boxes if you want to like write some stuff. So it's all there for you. All that good stuff. It's like a good reference. So I encourage you, whenever you're going to do plotting, maybe like open this up in a tab next to you and just kind of have it for reference. It's really good. It'll help you with homework. Yeah. This is on the B courses. So if we go to files and then you go to resources down here, we have several resources like this, but Ultimate Plotting Guide is right here. We also have the Python fundamentals if you're struggling and forgetting all the syntax and stuff. We have one there, and then we also have more advanced Python concepts like recursion, I believe, is in there as well. So if you're, forgetting how something works, this is kind of like, I don't want to say a textbook, but it's like a good reference for you to go back to if you forget how certain things work in Python. And we're going to keep adding to this. We're trying to add more and more of these every semester. So I believe this semester we're going to add like how to handle errors and stuff in Python as well. So that'll be coming shortly. Is there any more questions? Okay, so now let's get back into today's lecture. Hopefully the folks on Zoom can still see my slides. Can I get a comment in the chat letting me know if you see the slides still? Yeah, okay, good. All right, let's get back into it. So that I just wanted to point that out, make sure I didn't forget about it before it gets too late. That's the Ultimate Plotting Guide. I keep telling you about it. I say it like every lecture at least 10 times. Please take me up and actually like check it out. It's worth time, I promise. And today I want to talk about pandas. So previously we loaded in data, but it was kind of ass. I don't know if you noticed that, but an np.loadText is kind of a pain in the ass to work with. I get that, but I had to show it to you because not everybody knows about pandas and is not enlightened. I want to enlighten you about the easy way to do it. So pandas is a really cool library of code that we can use to create like a new object, and we call that a data frame. And that data frame allows you to kind of read in tabular data that you might see in like a spreadsheet into Python very quickly, efficiently, and easy to read, and it's easy to read. So let's go ahead and get into it. It's actually maintained by, I believe it's maintained by Meta or like the Facebook people. So they're good at coding, and it's like efficient and all that good stuff. And it looks pretty cool. So in Python, you can make a spreadsheet that looks like this, and I'll show you how to do it in a little bit. So the way you use it, importing it, or you import pandas by import pandas as PD. This is the common, like the most common like way we import. PD is the common acronym we use, or alias we use for pandas. This library usually imports data files with a lot of ease by storing them into a new data type. Like I said, this is called the data frame. It looks like this, where there's like rows and columns, and you can access these rows and columns with a whole bunch of syntax that I'll show you later. The way we read in data, before it was kind of annoying where you had to like set the delimiter and then do an unpack maybe if the array was like the wrong way or was transposed the wrong way. Now it's super easy. All you do is pandas.read_CSV for a CSV file, and you can just give it the string name, and it'll just automatically read it in as a data frame for you. And it'll be super easy to use, and it'll look like this in Python. Super nice. You can also load in different types of data files pretty easily. It has something for Excel spreadsheets. It has stuff for like HDF5 files if you ever deal with huge amounts of data. You can still do .text files, whatever you want. They got it covered. As long as it's like kind of in a tabular format, you can definitely read it in. So that is pretty useful, and it's simple syntax, .read underscore whatever the name of the file typically is. And you can just Google it if you don't know. You just give it the name of the file with your extension, and then set it equal to this data frame object. And now the data frame can be converted into things that you're more familiar with. So data frames are a little annoying to deal with when you want to do complex things like, I don't know, calculate the Fourier transform of it or something that you might do in NumPy with one line. It might be a little bit more complicated to deal with a data frame because NumPy doesn't know how to handle that. So we can always convert a column of this data frame. Remember, a column looks like this. You can interpret that as an array, a 1D array. So we can actually convert that to a 1D array through like .to_NumPy. It's just a little function that you tack on at the end of the object with your column name that you want, and then it converts it to a NumPy array. So this is a really easy way to pull out all the column values of a specific column. If you want to convert, like, if you want to use a list instead of an array for some reason, you can also do to_list. Here's a nice example of that. And that's often a common use that I use data frames for. I load in the data, so it's a nice, easy data frame, and then I just want one column of my data. I want all the values of them, and I just convert that straight to a array or a list. And notice how I'm indexing by a column name. Does anybody remember how we index dictionaries? Kind of ring a bell? It kind of looks like a dictionary the way we're indexing it. You're indexing it by a string, not by a number. Like a normal list, we index by a number like 0 to whatever the number you want, maybe the 10th element or something. But a dictionary, we have those key and value pairs. Remember, so you could look up a word in a dictionary, a string. Maybe it's like, I don't know, the name of your whatever object you're looking at, and you can pull out the values that correspond to that object. So remember, dictionaries had those key and values. It's the one with the curly braces. It's the same syntax. You can actually index those columns. You can treat them as key and value pairs, where each column is a key, or the name of each column is a key to the value that is a list of values at under that column name. So you'll see the similarities between dictionaries and data frames. In fact, you can create data frames from dictionaries. They're kind of like the same thing. Just a little bit more sophisticated. Is there any questions about this so far? Okay. If not, we'll move on. So let's go ahead and get into how we make our own. So to make your own data frame, let's say you have a list of names and you have the years they're born, or the number of, for example, I have the names of people from the office and then the number of births corresponding to that name in a given year. So the name Jim has 9,837 children born in some year with that name. Dwight with 8,688, and then so on with the rest of the names. So every name has a corresponding number associated to it. That's basically all we need to know. If we wanted to store it as a dictionary, the way we would do it is give it like a name, like a string, like names. We can reference that entire list by like a column name names. And then similarly, we could do birth counts with the word count. And this is creating a dictionary. And you will see that the column names are the keys and the data values are the values essentially of the dictionary. This will get mapped to a data frame. So the way that'll look is like this. So to create the data frame from that data, all we do is pd.dataframe and you feed it a dictionary and it'll automatically convert it into this format of this object, this data frame object. So and we usually save that as a new data frame. So df is equal to pd.dataframe, and then you put the dictionary you want to put in, and it'll create a data frame from the dictionary. So remember, names was the column name, that was the key. The value is this entire column or list of values. Count was another key, and then these numbers correspond to that key, the values to that key. Okay? Yeah. Yeah. So just to reiterate, names is a key to a value pair. Names, I mean, horrific naming or variable names on my part. This is why you should be more descriptive. But the column names are in strings, and then the colon separates the key and value, and then the comma separates the key value pairs. So this is all one column. This is all another column. And then the green arrows denote which ones are names, and the purple denotes which ones are the lists or the values in that column. Okay. And then if we want to, like I said, we put that dictionary into the data frame function and create a data frame from it. Then voila, you could save it as a CSV by just a simple little function .to_CSV, and then the name of the file you want it to save it to. So this can be any file name that you choose. It'll save it as that file in a CSV format. If you do to_CSV, you can also do like to_ like HDF5 or to_XL, and it'll give you like a different file name, as long as you make sure that the dot extension is correct with it. Okay, so this is an easy way to export your data. Once you've made a dictionary with all the data in it, convert it to a data frame, and then just to CSV, and you can share it with a colleague just like that. Super easy. That's why Pandas is like gorgeous. It's beautiful. NumPy load text could never. Okay, that's it. That's like that's Pandas. I mean, there's other stuff you can do with Pandas. Don't get me wrong. You can go to this documentation guide. In fact, I encourage you to, but just know she's kind of thick. Hold on, let me see. Let's open it up. Will it pull me there? Yeah. Look at this. It's gonna take a hot minute. This documentation is very big. We're loading it. I think it's like 2,000 pages long, maybe, or like 1,000. It's a lot, but like I said, it's maintained by like the people that made Facebook. So they're really good at coding, and 3,700. Yeah, it keeps growing. But literally there's like a table of contents, user guide, 10 minutes to Pandas. You can click on that and it'll literally take you through like walkthroughs of how to use their stuff. And there's so much you can do with Pandas. Oh my God. Like, I'm showing you the very basics just to read and write data, save data files and open data files, but like you could do so many things. It's not even funny. I'll let you explore that on your own if you're curious. Just know that Pandas is, like, in my opinion, the easiest way to deal with tabular data. So that's data that looks like a spreadsheet. Could be saved as text files, ASCII files, CSV files, you name them. Even JSON files if you've ever used with JSON. I think some of you had interest in like doing like JavaScript or something someday, like web design. Oftentimes you can use these in parallel with that as well. So Pandas is extremely useful for all of that good stuff with data. And you'll get a chance to use it. I think one of the review problems is even on Pandas. If you feel like you're comfortable with everything we've covered so far in the class, you just want to jump straight into some new stuff. So Pandas is very useful. And I believe I have a little bit of a demo for everybody. So I uploaded some resources. I uploaded like a demo notebook. I think everybody should be able to see it. This is like in my way. I want to get rid of this. Yeah, if you go to the B courses, under lecture demos, there's Pandas here. If you just download everything here, there's the COVID data as well as the solutions and the demo notebook itself. The demo notebook looks like this. I think for the interest of time, I don't really have a ton of time, so I'm not going to code live because I want to make sure we have lots of time to review, at least 20 minutes. So I'm just going to show you straight up the solutions. I encourage you to try to go through this on your own without looking at them, but we're just going to skip ahead a little bit just out of the interest of time. So here's the solutions. And I'll do my best to kind of slowly talk through it. So go ahead and make this bigger. Don't worry about this. This just makes it look pretty. We don't need that for now. If you're curious, check out the plotting guide or ultimate plotting guide. So the way it works, we have a data file, COVID data.csv, just some column or some tabular data separated by columns. I do pandas.read_CSV and save it as a data frame. Usually common practice or good practice, if you are saving a data frame, put like an _df at the end so that people know it's a data frame instead of something else, and for you as well. And then we can look at what this data frame looks like, and you can see it's like a nice, like it looks like a spreadsheet basically. So we have like dates, we have total cases, new cases, smooth values, deaths, all that stuff. I was gonna say good stuff, but it's definitely not good stuff. And we can use that data, use these columns of data and plot them. So if I want to, I could plot this data against time. Now I happen to know the x values ahead of time, and I'm not plotting like every single date on the x-axis because that would be like hundreds of strings and it just would look bad. So what I did was I went ahead and found what like indices in the column, so like what rows correspond to like that month. So all I did, it's not sophisticated. I just went, I was like, okay, 1, okay, I just went till I found a 2, and then I copied that index right here. This is like the index, like how you would use in a list. I found that index that corresponds to each month, and I just mapped them so I have locations and months. That way, it like I can make the pretty x-axis. Then we use plt.subplots to make 2 axis objects, 1, 2. They'll be side by side, rows and columns. And then I give it a fig size just to like make sure it's really wide and not like scrunched up. So 20 by 8. And then I have this ax1 object. I could set its title. I could plot a bunch of different lines. So in this case, I did like new cases and new deaths, smoothed and unsmoothed. So you can see the raw data in like a nice line. And then I could set like the X tick and X tick labels. This is in the plotting guide. Don't worry about it. And this will be uploaded so you can check it out later. But those correspond to these indexes and their corresponding labels. So I'm labeling each index in the X array so that it gives me a nice pretty month instead. That's all I'm doing. And then I just give it a nice legend in a grid. And then I plot something else on the second plot. I think I'm total cases and deaths throughout the entire year. And then this one is new cases throughout the year. So if we go ahead and run that, it'll look like this. Oh, this is awful. There we go. Hopefully everybody can see that. Fine. So we made this. Pretty nice looking, right? Looks like maybe, I don't want to say something you'd see in New York Times, but it's kind of there, you know? You can like fiddle around with it until it's like exactly how you want it. But this is like already a pretty nice plot that you could show to somebody and be like, hey, this is COVID data. Look at that. So you can see the blue line is new cases or just like cases, and then the red line is deaths. Thankfully, the deaths is a lot lower than the cases numbers. That would be bad if they were flipped. And then in this case, on the left case, you can see x-axis is date, right? And then y-axis is the number. So, 10 to the 6th. So this is like on the order of millions of cases we're seeing. And then you can plot like the data with like the smooth average and stuff on it. But this is just using pandas to do plotting. We talked about plotting a couple weeks ago and last week. So we should be kind of comfortable with the idea of plotting. We're just using pandas to get the data that we're plotting in this case. And then you can create and store your own files. Let's say you wanted to store like the months and indexes that correspond, or indices that correspond to those months. Make a dictionary where we have the column name be months. I'll zoom in. And then that like months column name is like the list of months we had. Same thing with the indices. And I set that list equal to locations. That's the name of the variable. So we make this dictionary, we feed it to pandas.dataframe, and then we create a new date locations data frame from that. And then this is what it looks like. And then you could save it just doing 2_CSV and then the name of the file. That saves it as a CSV file that you can send to somebody via email or whatever you want. So that's it. I'm sorry I rushed through that very quickly, but I do want to get to the review. I want to make sure we have plenty of time for review. Is there any questions? Okay, don't worry, you'll have lots of practice with pandas. It'll be in your homework. It can be in the review if you want it to be. And there's plenty of problems that'll be coming your way with pandas. So you'll have lots of time to digest it and get it in to your daily routine of coding. Okay, I think that is just about everything. I hope you appreciate my meme. Oh, it's not like, it's a GIF. It's not working though. Yeah, there we go. Demo time. Yeah, I'm super funny. Okay, anyway, review time. That's what I wanted to say. So the way this is gonna work, let's like actually have everybody like stand up and get into like groups, not just like work next to you, but like stand up, and we'll make, how about we make 5 groups? I think that'll be good. How many people are in here? About 30 or 40? 20 to 30? Let's do, yeah, we'll do 5. So like you should have like 5 to 6 people in a group or so. Just find people around you and then kind of like all sit next to each other. I'd like everybody to have group. And I'll show you where the problems are. Go ahead and go to the B courses. It'll be under review problem or files and then review problems. Right here, review problems. And there's folders with every kind of problems you could need. So there's plotting, recursion, pandas, NumPy, miscellaneous challenges if you're up for something interesting, loops, command lines, all sorts of good stuff. It's all kind of there. So just pick whatever you want. If they're notebooks, you'll download the notebook, work on it like a homework assignment. I think everybody's familiar with how to download a notebook and work on it on their own computer. If you have questions, we'll all be here circling around. Happy to answer them. Okay? All right. The rest 20 minutes is yours. Have fun and find a group. Remember, 5 to 6 people to a group. And then people on Zoom, if you want to stick around, I can put people into a breakout room by doing this. There. Have fun in it if you want. And yeah, the problems will be on B courses for you to check out. All sad. They like all left.